Cool. So hi everyone, my name's Felix Palmer. I'm mainly a JavaScript and WebGL developer, and I'm going to talk today about 3D maps and software that I've been working on in that area. So there's kind of two parts to this talk. Originally, when I got in touch with Ed a few months ago, then it was going to be just about this project called Nasdam.xyz, but since then I've also launched another project which is closely linked to this, so I thought I'd take the opportunity to talk about that as well. Projects have a pretty obvious link, but I also think that for different people they could be interesting in different areas. So first of all, I want to talk about Nasdam.xyz. So this is a project that a website service that I built about 3 months ago, mainly because I needed like a simple elevation API, in my case, for powering 3D maps. But I thought that it was also something that could be useful in general to web developers. And I say web developers in particular because I myself am not really that much of a geo expert. I've come very much from the software side, and I do software in the GIST space. But when it comes to projections and using GIST software and all of that stuff, then it's not really my area. And my experience coming to this realm was a bit, it was a bit daunting. Basically, you come here and you have a lot of terminology that if you haven't studied this, you don't know, and you just want to get working with geographic data where you understand the overall concept that you want to describe a place. You want to know some information about it. You know what latitude and longitude is. But then when you start talking about projections and different data formats and specialist software that you need to know, then it can get quite complicated. So what I've built here is basically an API that lets web developers add elevation information to their applications. And rather than using some more kind of traditional binary format, then it's simply encoded in a PNG file, which you might have seen other services do. It's used by Mapbox. They do something very similar. And what I really like about this approach is that even if you don't understand anything about software, you can look at these files in your browser or in an image editor and understand straight away what's going on. Like, it's a really easy entry into this space. So you can easily inspect it. The reason this site is called Nasdam is because it's based on a data set from NASA called Nasdam. This is from a mission they flew almost 20 years ago, but they recently, I think it was last year, they actually released the data. And it's not the highest resolution data set you can get, but it is global, and it's pretty consistent. So if you're using it into an application, then you can be quite sure there's not going to be any holes in your data or weird spikes or holes or something like that. So I just want to quickly go over how this actually looks. You might also notice that I've put a few helpful hints from Ed into this talk. These are hints that he gives the speakers. So I just want to put them here to show Ed that I did actually read his email and that I took his suggestions seriously. So the first one was screenshots of source code are boring. So this is the extent of the source code in this talk. Hopefully Ed can figure. So this is basically just showing how the data from the Nasdam service looks. So to use this service, you basically make a request, be it from web application or a script or from a mobile app, and you specify two coordinates. So that's the X and Y. This is longitude and latitude. And then the Z is the zoom. So that's where the XYZ comes from. So hence Nasdam.xyz. And you get back something that looks like this. So it's basically an image into which you've encoded the elevation data. And to get it out is really simple. You just use this formula here to combine the data from the red and the green. And you can also use the blue channel, but we're not using it in Nasdam. You can extract the height, any kind of pixel location in this way. And you can already see from this image that you kind of have this kind of contour pattern coming up. You can see that it's representing in image space what you have in the world. And if I just zoom through and show what the actual location looks like, and you can see how it nicely maps to the actual imagery in that place, which I think is pretty neat. This is all you basically need to understand to use Nasdam and get an elevation for a place. And it's something that I wish I'd come across all these years ago when I got started with this. So what can this be used for? So for me, it was 3D maps. I'm going to talk about that in a sec. But you can use this for any kind of application where elevation is important. So you can look up elevation at points. So you could look up elevation at cities, or I don't know, bus stops or mountain peaks, anything. All you need to know is some kind of coordinates in X and Y. And these are kind of simple mathematical formulas that you can use to translate from that to where in this image you need to kind of look up a pixel. Once you figure out how to get to points, then you can also do elevations along a route. So for example, if you have a GPS track of a hike or a cycle ride that you've gone on, then you can then use this to show an elevation map of kind of the hills that you climbed and draw a graph, something like that. And then beyond this, there's all the kind of usual kind of advanced geographic things that you could do on a map. So you can use this data to calculate the slope at a certain place, which you can do to do some hill shading, or figure out the aspect, or even do something like calculate how many hours of sunlight you're going to have at that point. Okay, so to summarize, then Nasdam is a service which you can just get to on www.nasdam.xyz. Sign up is very simple. Given that it's useful for developers, then I'm just using GitHub as a way to sign up. And there is a free tier available if you just want to try it out. And that's pretty generous at the moment. Okay, so now I want to move on to the second part, where I want to talk more about 3D maps, because this is really it's kind of my thing. I started with this about 6 or 7 years ago. You can see the screenshots on the left where I was just playing around with some demos where I was using random noise to just generate kind of snowy mountains and things like that. And over this last 6 or 7 years, then I've been mainly doing this on a commercial basis. But last year in December, then I launched a new library called Procedural Gl. And this is an open source library. So it's quite a change in direction for me. And that's what I'd like to talk about today. So Procedural Gl, GS, is quite a mouthful, I'm sorry, is a 3D mapping library. And the focus is very much on a very seamless user experience on mobile and good performance. I want it to be as easy to load a map as it is to load an image. It shouldn't be something that feels like you're waiting for an app to load or some kind of different experience to come in. You should be able to open a web page and the map should just be there for you. And at its core, then what makes this library different is that it has a GPU-powered level of detail system. This kind of sounds like a technical mumbo jumbo, but basically what it means is it's using the graphics card to decide which bits of the terrain it should display in high resolution and which ones it should do in low resolution. And this is typically something that is done on the CPU. And in particular, this is very useful on mobile devices because that is an area where the GPU has been getting better and better and better. Like, it's pretty impressive, the stuff you can do on phones nowadays. But the CPUs are actually quite slow in comparison with desktop software. So actually moving algorithms to the GPU is quite a big win on mobile devices because they can be a lot more power efficient and let users use them without their browsers getting stored up. You can stream in standard raster imagery tiles, so you can connect this to pretty much any data source that you have. And then it's easy to include elevation data because it's seamlessly integrated with the Nasdam service I was talking about before. On top of this, you generally want to show something, so some points or lines. So there's a powerful overlay function that lets you draw markers and lines and style them in lots of different ways. And you can then control the software with a powerful but not overcomplicated API. I want to make this something that is simple to build nice applications with, but not expose absolutely everything and confuse developers. But of course, it's open source, so you can do whatever you want with it. So now I'm going to take a bit of a risk and try and show you a demo, even though Ed told me not to do so, or encouraged me not to do so. So here, it's pretty much the same image that I had before, but it's a full screen version of the software. I'm not quite sure how well this is coming through on the stream, but at least on my computer, it's running full screen and pretty smooth. I'm not going to go through all the features here. It's just to give you an idea that it works, that as you pan and move around, it's loading in the data and seamlessly replacing it. I can try and switch to a 2D view here to show you kind of how it maps to kind of more traditional 2D map, or even load in another location. Here, somewhere in Switzerland. By the way, here I can really recommend Ed's company. That's what we're using here for this lookup. It's pretty much the only place that actually knows what Mont Blanc is. You put this into a bunch of APIs and they give you like a restaurant somewhere in Texas. So good job, Ed. So just quickly, I want to jump and show what I mean about these overlay capabilities. So this is like a demo that I'll link to later, where there's just a bunch of different examples of how you can add overlays to the map. And it's really as simple as taking GeoJSON, which is a very well-known format, and just specifying a location and some properties, and then all of these things just get drawn on your map. So with this, can make some more kind of complicated overlays where as you zoom in, kind of more stuff shows up. You can specify colors, font size. You can do things like saying where you want to anchor your data. And all of this stuff is actually getting rendered in the 3D world, like it's in the right place and it's all hardware accelerated. So it runs really smoothly, even on mobile. Let's just go back to the slides. So for a couple of use cases, one is data visualization. So anything that involves something spatial, then if you have an attractive base map to show it on, especially if it's somewhere 3D, then it looks really great. I've actually been working with someone these last few weeks who's been using this to do a visualization of all the pollution that came from the forest fires in California. So it's a bunch of bar charts distributed over space, and it animates them over time, and that looks really nice. Another use case is tourism. So if you're going to show someone where your hotel or your ski resort is, then it's really great to be able to show them that in 3D. And typically, I think the problem was that you can show an image or you can show a map, but a lot of websites, if they wanted to embed a 3D map, then the experience was not ideal. Like often people said download a plugin, or it was too heavy for mobile devices. So the hope was with this library, which is a lot more lightweight than some of the alternatives out there, then it really should be as easy as including an image into a web page. Another one is gaming. So this could be used for making a flight simulator, or I don't know, you could just use your imagination, any kind of game that needs the real world. And finally, maps. I mean, it's a 3D map, so of course you can use it for different kinds of maps. You can overlay hiking trails, or you could use it for winter sports to either plan where you want to go or relive where you've actually been, so show the routes, things like that. I can see I have a couple more minutes left, so I'll just show you quickly another demo of a simple application that I built. So this is just up on GitHub. It's like a directory of peaks in Austria. So I can scroll here, select the peak, and it just shows in that place. The reason it's white there is because that's Germany. And I'm basically using a data source from the Austrian government, which is free. It's also a demonstration of how you can integrate this with someone else's data source. But because it's the Austrian government, then Germany is snow white. Okay, so that's pretty much everything from me. So I'm just going to put up a few links here to both the Elevation API and this project on GitHub. If you find this interesting, then I would appreciate it, of course, a star on GitHub, or if you really like it, then I also have a sponsorship page up on GitHub, because this is something where I want to be able to work on it long term and be able to support it for free. I would rather not go down the commercial route. I think this is something that is kind of missing a bit in the open source space, and would be really great if people would use it to build cool experiences with. Yeah, that's all. Thanks.
Very nice. Very nice, Felix.
Very neat, and congratulations to Felix for ignoring Ed's advice and getting away with it. I wouldn't recommend that. I wouldn't recommend more of you doing the same thing, because one of you will fall over and then Ed will have a good laugh at you. Felix, I've got a couple of questions here for you. The Nasdam library or service, that only works with NASA data, or does it work? Could you load other data into it?
I mean, in principle, other data could be loaded into it, but
you'd have to do it.
I would have to do it. Like, think of it more as a way of getting at NASA's data in an easy way. So if you want, you can go to NASA's website and then click some links and download some data, which is hard to work with, and then reprocess it. And if you know how to do this, that's fine. But if you think of it from the perspective of someone who just wants to make an application and wants elevations, then they can just connect to this.
Okay, thanks. And the second question was about your Procedural Gl JavaScript library, and you said it's open source. Are you getting contributions from other people?
Well, it's only been open source for a month, so I haven't. At the moment, then I'm basically planning on keeping the core of it something that I'm working on myself, because I understand it. But there's bits around it where, for example, like a binding for React and stuff like that, where I would definitely appreciate some help. But at the moment, I haven't had any offers for contributions. So it's been me doing it, yeah.
Okay, well, let's hope that after this, and certainly when more people watch the video afterwards, when we publish it, you'll get some contributions coming in. Okay, everybody unmute and let's say a customary geomob thank you to